Hey, what's going on, you guys? It's Mr. O'Keefe. I'm just here trying to show you the elimination method for systems of linear functions. We've been working on drawing a diagram using the substitution method, graphing, and this is elimination with specifically multiplication. So remember, with elimination, you have to have your equations in standard form, which means you've got your x's, your y's, and then your whole numbers over here. Sometimes they call that the z. And then once your equations are set up that way, you want to try to add your equations vertically so that when you do, one of the variables eliminates. Either the x's, the y's um, will eliminate. So in this case, neither one of them are going to eliminate. Here I would get a negative 11x, and here I would get a 12y. So my choice is going to be to take this top equation, and the rule in math, multiplication property equality, says I can multiply both sides by whatever I want, and as long as I do that to both sides, the value won't change. So in this case, I'm going to choose to multiply it by a negative 3 on both sides, and that's going to change this middle y term from positive 3y to negative 9y, and then I can eliminate. So when I rewrite this down here and I use that distributive property, this turns into positive 3x, this turns to negative 9y, and then this turns into positive 33 because you got to pay attention to your signs. Now all I'm going to do is add the columns. So when I have the x columns, there they are, and I combine those terms right there, I end up getting 7x, negative 7x. And then here's the eliminations, why it's called elimination. Positive and negative 9y goes away. Bring your equal sign straight down. This becomes 49. Then you divide both sides by your negative 7, and you get your x value is negative 7. So then the next step is substitute that negative 7 back into either one of the equations. So I'm going to sub it into this blue equation. So normally it's negative 10 times x plus 9y equals 16. But instead I'm putting that negative 7 in there for the x. And then I'm just going to simplify following those order of operations and what I know about equations. So this changes to positive 70. Still have my 9y right here and still 16 over here. Subtract 70 from both sides. Bring down the 9y. 70's cross out. This turns to negative 54. So then I divide both sides by 9. My y value is negative 6. Remember, your solution needs to be where these two lines cross, right? The orange line and the blue line. So where they cross, you have to give whoever is reading the problem the directions. So you have to list it as an ordered pair. Go to the left 7, and then drop down 6, and that's the solution to the system. Again, elimination with multiplication.